Welcome to qnawire.
So here for part A, we know that the disk starts from rest, and so the velocity of the center of mass is in the direction of the net force. So we can say velocity final vector would equal the velocity initial vector plus the acceleration vector times t. Therefore, the final velocity vector would be equal to the net force vector multiplied by t divided by the mass. Therefore, the center of mass moves to the right. So center of mass moves to the right, given that this is positive. For part B, when we want to find the final linear velocity, we can apply the constant acceleration equations, where the acceleration would here be equal to the force divided by the mass. So we can say that velocity final squared equals velocity initial squared plus 2 times a delta x. We know that the initial velocity squared term is 0. Therefore, the final velocity would be equal to the square root of 2 times f delta x divided by the mass, and we can solve. So the final velocity would then be equal to the square root of 2 times 35 newtons multiplied by 5.5 meters. This would all be divided by the mass of 21.0 kilograms. And we find that the final velocity is 4.28 meters per second. So this would be your answer for part A and your answer for part B. For part C, we know that the only torque is a constant torque caused by the constant string tension, so we can find the angular velocity. The torque would be equal to the moment of inertia times the angular acceleration. This would be equal to I times the final angular velocity, given that the initial angular velocity is 0, divided by t, and due to the definition of torque, this would equal the force times the radius. So the final angular velocity would be equal to the force times the radius times time divided by the moment of inertia. This would be equal to force times the radius times time divided by 1/2 mr squared. And this is equaling 2 times the force times t divided by mr. And so the time can be found from the center of mass motion under constant acceleration. Therefore, delta x would be equal to vx initial t plus 1/2 at squared. We know that this term is 0. This can be eliminated. This would be equal to force times time squared divided by 2m. And so the time would simply be equal to the square root of 2 times the mass times the change in displacement in the x direction divided by the force F. And we're going to substitute this into this equation for the final angular velocity. So the final angular velocity would then be equal to 2 times the force times time divided by mr. This would be equal to 2 times the force divided by mr times the square root of 2 times the mass times the change in displacement in the x direction divided by the force F. This would be equal to 2 over r times the square root of 2 times the force times the displacement in the x direction divided by m, and we can finally solve. Omega final would be equal to 2 over 0.850 meters multiplied by the square root of 2 times the force of 35 newtons multiplied by 5.5 meters divided mass of 21.0 kilograms. This is equaling 10.1 radians per second. And we know that the amount of string that has unwrapped is related to the angle through which the disk has turned. So essentially, we can say for part D, S equaling R theta. This is simply just trying to find the angular displacement, where S is the unwrapped length. And we can say that delta theta then is going to be equal to the average of the angular velocities. So omega initial plus omega final. We know that omega initial is going to be 0. Therefore, this would equal omega, multiplied by time. So this would equal omega final multiplied by time divided by 2. And this would equal 1/2 times 2 times force T over mr multiplied by T. And we find that delta theta would be equal to force times squared divided by mr. This would be equal to F times 2 times m delta x. We're basically subbing in for T squared times F divided by mr. The m's cancel out, the f's, and this is equaling 2 times delta x over r. So delta theta, the unwrapped length would be equal to r times delta theta. This would equal r times 2 delta x over r. This is simply equaling 2 delta x, or 11 meters, equals the unwrapped length. That would be our final answer for D. That is the end of the solution. Thank you for watching.